Okay, let's look at the homework number 8, problem number 17. Right. So we want to sketch the graph of this function f of x, which is a rational function, 4x squared over x minus 3. Right. So let's look at that. Right. First part, we want to find the domain. Right. So let's do that. Right, so domain of this function, so we know that we want to make sure that the denominator, so x minus 3, we do not want this guy to be 0. Right, so we can just add 3 to both sides. You get x cannot be equal to 3. Right, so if you go back here, right, so all domain is all real number except 4, so 3 is the only bad number. Right, let's check the answer. Right, we got that. Right, so the next question, right, we want to find x-intercept, then so let's find x-intercept. Right, right, in order to find the x-intercept, we set y equal to 0, so x-intercept, right, means that we're gonna set y equal to 0. Right, so which means that the whole function, we're gonna set the whole function equal to 0. 4x squared over x minus 3 equal to 0. Right, but if you want the fraction to be 0, all we have to make sure is that the numerator is 0. So we're going to have, right, 4x squared is equal to 0. Right, then you can just divide through by 4. So x squared is equal to 0. Then take the square root of both sides. So x is equal to 0. Right, so let's type that in. Right, so x-intercepts are just x equals 0. Let's check that. Right, we got that. Right, the next question, and a y-intercept. Right, so let's do that. Y-intercept is actually quite simple. Right, if you want the y-intercept, right, so what you do is set x equal to 0, right, which means that we just plug in, so y equals f of 0. Right, but if you plug in 0, 4 squared over 0 minus 3 is just 0. Right, so y-intercept is 0 as well. Right, right, type that in. Right, check the answer. Right, we got that. Alright, next question. We want to find a vertical asymptotes. Right, vertical asymptotes is a place where denominator is 0 and not the numerator. So x equals 3 is the one. Right, so it's related to the domain of this function. Right, so we got that. Right, the horizontal asymptote. Right, so we want to find the horizontal asymptote. Right, if you want to find the horizontal asymptote, what we need to do is we need to take the limit, or let's take the limit of the function. So it's 4x squared over x minus 3 as x approaches infinity. Right, then we want to evaluate this. But you can see that the top goes to infinity. So maybe I should write that. Top guy numerator goes to infinity as x approaches infinity. And the denominator also approaches infinity. Right? So we just learned how to use the L'Hopital's rule. Maybe we should use the L'Hopital's rule here. Right? So we apply L'Hopital's rule. Right? Then you have a limit as x approaches infinity. Right, derivative of 4x squared is 8x over, right, derivative of x minus 3 is 1, right? This goes to infinity, so you can see that the infinity over 1, so it's infinity, right? Which means that since we do not get a finite number, there is no horizontal asymptote, right? So go back. Hopefully we have that choice. There is no horizontal asymptote, right? Check the answer. We got that. Right, summarize the pertinent information obtained by f prime. Select the choice. All right, so we have to find a derivative. All right, so we take the derivative. So f prime of x. Right, so since it's a quotient, we're going to use a quotient rule. Right, square the bottom. So you have quantity x minus 3 squared. Right, and square the top. Actually 4 is just a constant, so I'm gonna put 4 out here. Right, so derivative of x squared is 2x, right, times the bottom guy, so it's quantity x minus 3, right, minus top guy is going to be just x squared, multiplied by derivative of the denominator, which is 1. Right, so if you simplify that, you will get, let's see, 4 is outside. Right, so you have 2x squared minus x squared. So it's going to be x squared. Right, and 2x times negative 3 is negative 6x over quantity x minus 3 squared. Right, so you will get, let's see, 4 here, and x is in common, so you have x minus 6 over, right, x minus 3 squared. All right, so we can set this equal to 0 so that we can find the critical number. Right, so we know that x equals 0 from here, and x equals 6, right? And also critical number, x equals negative 3, it's not a critical number, but we need to put the tick mark because function is not defined there. All right, so let's do a number line there. So you have a number line. Right, so we need tick marks for 0, and the tick marks for 3, and tick marks for 6. Right, so we know that, let's see, we talk about the derivative. Right, then at 0 and 6, right, derivative is 0. Right, and at 3 it's not in the domain, so maybe I should say just not defined. All right, then let's look at the sign. So f prime of anything less than 0, so I'll try negative 1. Right, so let's look at the sign. Right, if you plug in negative 1, so this is going to be negative, right, and negative 1, that's going to be negative. Right, bottom is always positive because of the squared, so it's going to be positive. Right, so you have a positive sign here. Right, between 0 and 3, so I'll try positive 1. Right, so if you put the positive 1, so this is going to be positive. Right, this is going to be still negative, that's positive, so it's going to be negative. So I'm going to put negative sign here. Right, so that's going to be negative. Right, let's try between 3 and 6. I'll probably try 4. Right, so this is going to be positive, that's going to be still negative, so that's going to be positive. So we know that this is going to be still negative. Right, so you have a negative sign there. Right, and after that we can try anything bigger than 6, so I'll probably try 7. Right, Then you have 7 positive. 7 minus 6 is positive. Everyone's positive, so it's going to be positive there. All right. So we know that it's increasing on infinity to 0 and 6 to infinity, and decreasing between 0 and 6, right, excluding 3, right? So let's type it in. All right, so it increasing on, right, negative infinity to 0, and also 6 to positive infinity, and decreasing on 0 to 3, and also 3 to 6. All right, let's check the answer. All right, we got that. All right, then we have to look at, we're going to look at local max and a local min. All right, so let's go back here. All right, so we know that we can have here. So this is a critical number. It's increasing, going to decreasing. So you have a local max here. So here you have a local max, right? And here decreasing to increasing, so this is going to be a local min there. All right, so local max at 0, local min at 6. All right, so let's go back. All right, so local maximum at 0, and a local minimum at 6. All right, let's check that. All right, got that. All right, summarize to obtain the second derivative. So we want to look at the second derivative, then talk about concavity. All right, so let's do that. All right, so we take another derivative here. So let's see, let's take the derivative of this guy. All right, so f double prime of x is equal to, right, 4 is out here. Right, so square the bottom, so you have a quantity x minus 3 to the 4th power. Right, derivative of the first guy is 2x minus 6, right, times the bottom guy is a quantity x minus 3 squared, right, minus, right, so you have x squared minus 6x times derivative of the bottom is 2 quantity x minus 3 to the 1st power times 1. So you just get that. All right, let's clean this up a little bit. All right, so you have 4. Right, so let's pull out what's in common. Let's see, we have x minus 3, and there's x minus 3. Actually, there are 2 of them, so I'll circle here. So x minus 3 is in common. Right, and what else? I guess not much, so I'm gonna just multiply it out. All right, so what's left is here 2x times x is 2x squared. Right, 2x times negative 3 is negative 6x. Right, and 6 times negative times x is negative 6x. Right, negative 6 times negative 3 is positive 18. Right, then from here 2 times x squared, so it's going to be minus 2x squared. Right, so it's going to be negative negative, so it's positive 2 times, so it's going to be 12x. Right, then you have x minus 3 to the 4th power. Right, so we can cancel x minus 3 and one of these guys and turn it into a cubic power, and also we can cancel 2x squared and minus 2x squared, and you have a negative 6x, negative 6x, and a positive 12x. Right, so what's left is really just let's see, 4 times 18, right? All right, so 4 times 8 is 32, and 4 times 1 is 4, so it's a 72 over quantity x minus 3 cubed, right? So this is the second derivative, right? So let's do the number line here. So if you do a number line, right, so negative 3 is the only 3 is the only thing tick mark we need, right? So f double prime, right? Then we can try anything less than 3, so I'll try 1. Right, if you plug in 1, so that's going to be negative. Negative cube is negative, so it's going to be negative here, right? So you have a negative sign. And you can try anything bigger than 3, so I'll try 4. Right, 4 minus 3 is positive. Everyone's positive, so you have a positive here, and you have a positive sign there, right? So you know that it's going to be concave down. So concave down, f is concave down here, and concave up from 3 to infinity. Right, so let's look at that. Let's type it in. All right, so it's concave upward, starting from 3 and up, so infinity, and a concave down on negative infinity to 3. Right, so let's check the answer. Right, we got that. Right, then find the inflection point. Right, so we want to find the inflection point, but we know that here concavity changes at x equals 3, right? And we are attempting to say that there's going to be an inflection point there, but the 3 is not included in the domain, so there is no inflection point, right? So there is no inflection point, right? So we got that. All right, then we have to pick the right picture here, all right? All right, so we just said that it's going from concave down and a concave up. Let's look at the picture. All right, open this up. All right, this is concave up, concave down, so this is not it. Concave up, concave down, this is not it. Concave down to concave up, concave down, concave up. So either it's going to be C or D, right? Another thing is that we have vertical asymptote at x equals 3. So we have that. So let's find, right here, vertical asymptote is on the negative side. This is vertical asymptote is on the positive side. So this gotta be the picture. All right, check the answer. All right, we got that. All right, that's it. I hope that this was clear.